So let me tell you that Adaboost and related algorithms, they were recast in a statistical framework first by Bremen, calling them arsing algorithms. The full form of arsing algorithms is adaptive reweighting and combining algorithms. Okay, Bremen called them arsing algorithms, and this framework, this arsing algorithms, they are further developed by Friedman, and he called this as gradient boosting machines. Okay, later on, it is just called gradient boosting or gradient tree boosting. Okay, so this is the basic history behind gradient boosting. So let me tell you that gradient boosting, it relies on the intuition that the best possible next model, when combined with the previous model, minimizes the overall prediction error. Okay, as we combine all the models together, they tend to minimize the overall prediction error at the end. Okay, the key idea is to set the target outcomes for this next model in order to minimize the error. Okay, you will be understanding more about this algorithm as we will discuss its working. Let me tell you that this algorithm, again, it can be used both for classification and regression problems. Okay, so this is the figure for the working of gradient boost. As you can see, we passed a data set to our first model, and then we calculate the residuals for from this model, and we train on next model based on these residuals. Okay, so how you calculate the residuals, what you do, that we will discuss in the working. This is just to give you a basic idea about gradient boosting. Okay, so now before starting the working, i would like I would like you to see uh, these three important things about gradient boost. One is the loss function that needs to be minimized. Second is the weak learner for computing the predictions and forming one strong learner. And at last, we have one additive model that will regularize the loss function. Okay, we will be discussing one by one about all these three things. First, we will talk about the loss function. What is this loss function? Okay, so now, as you know, that we have various loss functions available with us. Okay, for regression, you can use you can use squared error. For classification, you can use logarithmic loss. Okay, uh, so there are various loss functions. Okay, you can choose the loss function according to your problem statement. If you are using regression, you can use squared error or any other loss function. If you are using classification, my suggestion is to use logarithmic loss, because there is one condition in gradient boosting. Okay, as you can see that in gradient boosting, the loss function, it needs to be differentiable. Okay, we can only use the loss function that is differentiable. Okay, you can even develop your own loss function. You can define your own loss function. There are many standard loss functions that are differentiable, but you can also define your own. But the condition is that there needs to be differentiable. Okay, now the weak learners, the okay, the weak learners, the decision trees, they are normally used as the weak learners. Okay, as you have seen in Ada Boost, what we have done, we have made a stump. Okay, stump just with one node and two leaves. Okay, that is the weak learner for Ada Boost. In gradient boost, you can build larger trees. Okay, larger trees that can be generally with 4 to 8 levels. Okay, you don't have to make a decision stump, you have to make a whole tree. Okay, now these trees, they need to be constructed in a greedy manner that choose the best split points based on purity scores like Gini, or to minimize the loss. Okay, uh, this is to ensure that the learners, they remain weak. Okay, you don't have to build the whole decision tree algorithm at all. Okay, You should make a trees like that they remain weak, as they are weak learners. So you have to ensure that they remain weak, but still they can be constructed in a greedy manner. Okay. It is common to constrain the weak learners in a specific way, such as you can define maximum number of layers, the nodes, splits, or leaf nodes. These all things you can define while you are building a decision tree for gradient boosting. Okay, now we will discuss about additive model. Okay, uh, uh, these when we will be discussing about the working, at the last step of the working you will see that we will be combining all these weak learners together in order to make one good prediction. Okay. uh, I think you all are aware about the gradient descent approach. Okay, let me draw its figure with the help of a pen. Let's say we have something like this graph and we have this curve. Okay, it's is try to understand, this is a convex curve. Okay, now what we do in gradient descent is that, let's say if we start, this is our global minima, this is our global minima. If we are starting from here, we take small steps in the direction of this global minima. Okay, pardon me for my handwriting. I think you can understand. We are taking these small steps to this global minima. Okay, the similar approach we will be using in gradient boosting algorithm also. We will be calculating the residuals, and and at the end we will be combining the output of all the trees together in order to give a good output. Okay, as you know, in gradient descent what we do is we have a fixed number of trees, and they are in gradient descent. What we do is we have to reach to this global minima, and once the loss reaches to an acceptable level, or we can see that no longer improvement is taking place, or trading stops there. Okay, the similar approach we are going to follow in gradient tree boosting also. Okay, you, it will be more clear to you when we will discuss its working. So now let's start about the working.